Right, for this question I've just cut and paste some things so it's all on the same page. But the important thing is we've got this graph for an LDR and we've got this a circuit, and this 3A and with the question 3B is your voltage divider question that they ask every year. Voltage divider. Right, so I've got an LDR, this is the characteristics, the light intensity versus the resistance in kilo ohms. And here's the circuit we're testing with. Calculate the intensity of light falling on the LDR when the current is equal to 2.5 milliamps. So we've got current here. So how do we calculate the intensity of light? Well, the only really way we know to calculate the intensity of light is using this graph here. So we need to use this graph to calculate the intensity. To do that, we need the resistance of the LDR. So really, that's what we're going to find out. This is working backwards. If we can find the resistance, then we can find, using this graph, the light intensity, which is what they want. So we need to be able to find the resistance of this guy. Alright, well how do you calculate resistance through something? It's we've got V equals IR. So resistance equals V over I. So it equals the voltage in the LDR over the resistance, the current in the LDR. We know what the current in the LDR is, 2.5 milliamps, which is in amps, 0.0025 amps. But we don't know what the voltage is, damn it. Alright, well let's start by figuring out the voltage, maybe in this guy, because if we can work out the voltage in him, if 10 volts is used here, and then say we find that 5 volts is used there, there must be 5 left over for him. So we can do that. So the voltage in the resistor equals the current in the resistor times the resistance of the resistor, which is again 0.0025 times 3000. When you do that on your calculator, you get 7.5 volts. So if this is 7.5 volts, and there's 10 volts, minus 7.5, there must be 2.5 volts left over for this one. So now I can put this in here, 2.5 volts in here. And you do that on your calculator, you end up with 1,000 ohms. Great, so I've worked out the resistance. It's 1,000 ohms. What does that mean? It means resistance 1 kilo ohm, 1,000 ohms. Here we go, lux is 10. Alright, again I've just copied and pasted the right information. It's in the wrong order, but that it was in the book, but here it is again for part B. Right, using the LDR, a 10 volt battery, a switching circuit and a resistor, design and draw a circuit to switch the light on when the light intensity is 2.5 lux or less. With these circuits, the first thing I do is I just draw the skeleton of the circuit every single time. So this one has a resistor in it, and it also has the LDR. What did the LDR look like? Like that. So it had some arrows going into it, and it had this circle around it. Alright, I know this is 10 volts. That's the first thing I always do, draw the skeleton. The second thing I do is figure out where does the switching circuit go. Where does that switching circuit go? This is something I have in my cheat sheet. So in my cheat sheet I'll say when it gets darker or colder, and when it gets hotter or brighter. In this case, when it gets hotter, when it gets this is getting 2.5 lux or less, this is getting darker, and this one always goes on the LDR or the thermistor. This one, when it gets hotter or brighter, that goes on the resistor, or sometimes they have a variable resistor. So it's getting darker or colder, so this guy goes on here. The other way to work that out, switching circuit, which I thing, it's doing a light bulb, is that this turns on when it's 2.5 lux or less, and the switching circuit turns on apparently when it needs 6 volts over it, or greater than 6 volts. So here's 2.5 lux, halfway between 0 and 5. When it's 2.5 lux or less, the resistance of this gets higher and higher. Here's lux 2.5, and as it gets less, it gets higher. So in terms of the LDR, as it gets darker, the resistance of this gets bigger, so it takes a bigger portion of the voltage, and that's why we know that it has to go on here. Anyway, that's the first thing. Where does that go? The second thing, the next thing is I draw the voltages in. So we know this apparently switching circuit needs to turn on when it's greater than 6 volts. This is in the question. So this has 6 volts on it. If that's 10 volts, that's 6 volts. This must be 4 volts left there. 10 minus 6 is 4. Once we've done that, we use ratios to find the resistances. At 2.5 lux, here we are, 2.5 lux, we have 3 kilo ohms for that. This is the LDR. So 3 kilo ohms is 3,000 ohms over this. Let's look at the ratios. Use ratios to find R. What's the ratio between that one and that one? Or how did I get from 6 to 4? I have to times by 2/3. So I have to do the same thing here. Times 2/3. Therefore, this must be 3,000 times 2/3 is 2,000 ohms. And that's it done.